Good morning. Today we are going to cover Geometry Lesson 8.4, Trigonometric Relationships Between Sides and Angles of Special Right Triangles. And so you're going to look into trig relationships between the sides and angles of, as I said, special right triangles. That's the important things. And of course, we're finding sides and we're finding angles. And this video solely supports Geometry IXL Skill R5. If you'll remember, I originally was going to include the information that is in this video here in the previous video, and I was going to include R5 course as support, or it was going to be supported, I should say, by that previous video. It turned out to be too long and I felt it would confuse you, so I'd split it up, and this makes it a little bit simpler. So we're just focusing on the trig relationships of special right triangles. Okay. Don't forget, you need to submit these notes no later than 11:59 p.m. and I'm extending it, the due date on this, to Wednesday. That would be February 17 at 11:59 p.m. Okay. All right. Okay, so this is a look at the theorems revolving around special right triangles. And we've already looked at this before, and it's a review. So you've got two types of special right triangles. So the first one is the 45-45-90 angle. The second one is the 30-60-90 degree triangle. And the important things that you want to remember for the 45-45-90 degree triangle is the square root of 2 times x. Okay? 2 times x. So once you find out what x is, then you can multiply the hypotenuse times the square root of 2 times that x value, and you have its value. The 30-60-90 degree triangle is as we see here. So if you know what the short leg is, x, then your hypotenuse across from the right triangle over here is 2 times that value, and the long leg is the square root of 3 times x. So again, this is just review. All right, now, because special right triangles are right triangles, they're also governed by the trig ratios. Now, we covered the trig ratios in 8.1. We covered we covered trig ratios in, I think, actually 8.1 and 2, and we covered in 8.3 we covered special right triangles, and this is 8.4. We're taking special right triangles and we're finding out their trig ratios. Okay, so that's basically all we're doing. And so these are the again, the ratios for sine, cosine, and tangent, and then these second ones here, these are the inverse ratios for sine, cosine, and tangent. Right? And I oftentimes suggest that you use the values, or I should say the labeling for the inverse ratios follows. Cosecant is just sine of -1. The secant is cosine of -1. And the cotangent is just tangent of -1. Or the inverse. Okay, inverse. All right, and then remember that you can use your graphing calculator to find the sine, the cosine, and tangent and their inverses. And so let's look at angles and sides of special right triangles using trigonometry. All right, so I'm first going to introduce to you an example that just shows you how to find the sine and cosine and tangent of 45 degrees. And so we're going to begin by sketching a 45 by 45 by 90 degree triangle. There's one right over here. And let's do this. Because all such triangles are similar, you're making calculations by choosing one here as the length of each leg. So these are the legs, they're 1. So we're going to let x equal 1. Okay. And that's for each leg. Then the hypotenuse, first of all, let's just say x equals 1 here. Right? The hypotenuse, it says it's the square root of 2, okay, but it's actually the square root of 2 equals the hypotenuse, and it's the square root of 2, excuse me, let me just write that, let's make this a little, so it's the square root of 2, and so the only thing you got to understand though is that it really is hypotenuse equals the square root of 2 equals x times the square root of 2. So if the hypotenuse equals x times the square root of 2, and x is 1, then the hypotenuse equals 1 times the square root of 2, which simplifies to the square root of 2. Okay, so the bottom line here is, even though it just says the square root of 2, you've got to understand that it's really the square root of 2 times 1. All right? So in other times, x is going to equal some other number like 2 or 3, and so you'd end up having to multiply this radical 2, square root of 2, times whatever that number is. That's the only thing that we want to make sure you know. Okay? So now that I've cleared that up, you can better understand now why the hypotenuse is showing us the square root of 2 in this particular example. So let's do the sine of 45 degrees. So sine of 45 degrees equals, if you remember the ratio, opposite over hypotenuse. Okay? And what does that equal? Well, let's substitute. Here's the 45 degrees. Here's opposite, that's 1, over the hypotenuse, that's the square root of 2. So it equals 1 over the square root of 2. Okay? That's it. That's your answer. But you'll notice that you've got a radical in the denominator. Now here's the thing. Even though this is the ratio, in algebra you may remember that you can never have a radical number like the square root of 2 in the denominator of a fraction. So what you have to do is you have to rationalize it. So rationalize, which means multiply the numerator and the denominator by the square root of 2. Okay, so that looks like this. Square root of 2 divided by the square root of 2 times 1 over the square root of 2. So you're just going to multiply across now. So multiply. And so when you do that, you're just multiplying across here this way. Square root of 2 times 1 is the square root of 2. Square root of 2 times the square root of 2 is the square root of 2 squared. All right, now, whenever you have the square root of 2 squared, square root of 2 squared equals 2, because if you square root of 2 times 2, well, 2 times 2 is 4, square root of 4 is 2, okay? That's basically all it is. So basically the radical and the exponent cancel each other out and you're left with a root, okay? So this equals square root of 2 in the numerator, and then the square root of 2 times 2 is just plain old 2. Now that's approximately, if you were to put it, to divide those, that would be approximately 0.7071. But the answer we want is this one for purposes of what we're going to be putting in IXL. So just be aware that that's usually the main one. But when you are doing sine, cosine, and tangent on a calculator, you will see it with a decimal result. The thing about a number that is left as a fraction with a radical in it is that it is simplified exactly, whereas this is an estimate. Okay, and so if they ask you to simplify it exactly, then that means you want to keep it in this fractional form. All right, so then we're going to do, let me put a line across here. Then we're going to do the cosine. I'm going to go a little faster now. The cosine of 45 degrees, that equals adjacent over hypotenuse. Okay? And the adjacent is 1. It's 1 again, because remember both of these sides or these legs are 1. So it's 1 over, and the hypotenuse again is the square root of 2. So we just have to go through the same rationalization, right? So we'll rationalize this number, and we'll do so by multiplying the numerator and the denominator by the square root of 2 times the square root of 2. I'm just going horizontally here because we're kind of low on space. So that multiplies together as square root of 2 over 2 again, right? And that also is approximately, if you want, 0.7071. All right? So the big thing I want you to note is here and here you have the same answer for sine and cosine. Now why would that be? Well, look at it. You have a 45 degree angle up here because this 45, 90 degree angle. The sides, the legs are both the same. So if the legs are the same and the adjacent angle for each of these is the same, you're going to get the same result. Okay? All right. So the last one we're going to do is the tangent of 45 degrees. So let me put another line here. So tangent of 45 degrees, and that's going to equal opposite over adjacent, as you know. Again, just check that table. And opposite over adjacent, well, here's opposite, here's adjacent. That's just 1 over 1, which equals 1. So you can see here with this special right triangle, because you've got the angles the same and the legs the same, your sine and cosine are the same. And your tangent is going to be a 1 because your ratio for the two sides are 1. Now, will that always be that way? Well, if every single time the two legs are the same, if I was using 15 and 15, 15 divided by 15 would equal 1. So that's always going to be 1. Tangent always will be 1. All right? So that's something useful you can use as a shortcut when you're working these. All right. So now I'm going to do a couple of problems that are, frankly, IXL problems. This is the way you see them. Okay? And so this says evaluate. Write your answer in simplified, rationalized form. Simplified means they want it reduced as much as possible. They want it rationalized, so you're going to be doing the fraction as well. And if you've got the denominator with a radical in it, then you're going to have to rationalize it. Okay, so this is for a 45, 45, 90 degree triangle. So I'm just going to sketch a 45, 45, 90 degree triangle at the top here. And so here's the right angle. Actually, I wanted that in red. Okay. And it has 45 degrees here and here. And so we know that our x is going to equal 1 in this example. Now, why 1? Why are we choosing 1 for this? Well, if they're just telling you to evaluate the sine of 45 degrees and they are not giving you any other information relative to, they don't draw you a triangle like this, so you don't know what x should be, then always assume x is 1, always. And then that allows you to answer these questions that you see here in IXL. So always use this format. So over here, x is also going to equal, x is always going to equal 1. And then down in the hypotenuse, we have x times the square root of 2. Okay, and so this is going to equal, x is 1, so 1 times the square root of 2. And so that's going to equal simply square root of 2. All right? So if you remember that, let's start out then with the sine of 45 degrees. Sine is opposite over adjacent. Okay? And so the sine of 45 degrees, let's start over here. is going to equal x over the hypotenuse. And what is that going to equal? That's going to equal 1 over 1 times the square root of 2. And you're substituting here, so let's just write in substitution, because you're substituting values.
This is getting
And then let's continue on then. So the sine of 45 degrees equals 1 times the square root of 2. So now we want to simplify that. So that's going to equal, I'm running out of lead here, equals 1 over the square root of 2. So we need to rationalize that, right? So we're going to multiply that times the square root of 2 over the square root of 2, right? So this is rationalized. And so then multiplying those together, we're going to end up with 1 times the square root of 2 over, remember, square root of 2 times square root of 2 is 2. And that simplifies into 1 over square root of 2. Right? Okay, so that's the answer that you would plug in up here. 1 over the square root of 2 in IXL. And then you click on submit and it should say, hey, you got it right. Okay. So again, all I'm doing is taking what we learned before in the example and I'm applying it now to an IXL type question so that you understand, you know, how you do this. Because I've had some students who looked at this and they go, whoa, you know, I don't know where to start because I don't know what, I don't have a you know, picture here that tells me that what x is. And so if I don't have a picture that tells me what x is, I'm screwed. Well, always assume 1 if they don't give it to you. Okay? All right, so let's do the tangent of 45 degrees. So the tangent equals opposite over adjacent. I'm going to go a little faster. We're going to assume what's going on here as simply as we can. So, and remember, the tangent of 45 degrees, which is what we're asking for here, is going to be, well, remember, opposite over adjacent, 1 over 1. So it's 1 over 1. And so this is in the form that IXL wants it. I'll just say that just to, in IXL form. So you put it in there, and then it tells you it's correct. Okay? All right. So now I'm going to do the same thing for 30 degrees. So we start out by sketching a 30, 60, 90 degree triangle. Here it is over here. And let me just kind of darken this. These radicals are kind of hard to see. So we're going to, again, to make our calculations simple, we want to use 1 as the length of the shorter leg. Okay? And so you're going to be doing this in IXL unless they give you a picture that gives you different values for these things. Okay? For x, actually. All right. So that means we're going to say that the length of the shorter leg is going to be x. This is the shorter leg of this triangle. So x equals 1. Okay? And then it follows then that the length of the longer leg has to be the square root of 3, and the length of the hypotenuse is 2. Now, why is that so? Well, remember, this is 2x 2 times x, right? But in this case, since x equals 1, two times x equals 2 times 1, which equals 2. Okay? So that's what's going on down here. And then down here, again, since x equals 1, this is really square root of 3 times x, where I'm going to put the x in the front. X times the square root of 3 equals, this I can do vertically a little more easily, equals 1 times the square root of 3, which equals the square root of 3. Okay? So, now you know why this is going to be, 2x is going to resolve as 2, and over here, x times the square root of 3 is going to be the square root of 3, simply because you're only multiplying times 1. All right, so let's go ahead and do this. Let's find the sine of 30 degrees. So the sine of 30 degrees equals opposite over hypotenuse. Okay, and so here's 30 degrees. Opposite is 1. Hypotenuse is 2 times x. So that's 1. Why don't we make it red? Okay, 1 over 2 times x. Well, why don't we do it this way? Why don't we show it as x? So x over 2 times x. And since x equals 1, that's going to equal 1 over, and this is 2 times 1, which equals 1 over 2. Okay? Okay, that is approximate. Well, that isn't approximately. That's exactly 0.5. So it does equal 0.5. That's the decimal, and a note that, you know, the calculator, it's just a note here. Calculator will give you a decimal answer. So, you know, it's easy when you get a decimal answer to go back in and click frac and come back with a fraction if the decimal is something like 0.5. 0.5 is a rational number. In other words, it can be divided into 1 divided by 2. But if you get something like 0.8660 or 0.7535 or something like that, those are not going to end up being neat fractions. They're going to be a fraction with a radical in it, and the calculator cannot go back with a frac function and come up with that. So, you know, you're stuck finding that by using this sort of method and using the fraction and saying, okay, that's it. Just something to know as we go along with this. All right, now let's do the cosine. So cosine of 30 degrees equals adjacent over hypotenuse. And that equals, in this case, so adjacent is x times the square root of 3, right? Which we said was 1 times the square root of 3. So x times the square root of 3 hypotenuse is 2 times x. And we know that x equals 1. So that equals, numerator equals 1, substituting, times the square root of 3, divided by 2 times 1. Okay, so that equals the square root of 3 over 2 times 1 is 2. Right? And that's approximately, on a calculator I worked it out, 0.8660. If you just took this into your calculator, divided the square root of 3 by 2, that is what you would get. So this is the answer that you would want to use in IXL, okay? The fractional answer. And you'll notice that the denominator here is not a radical. It's not a square root. So since it's not, you don't have to go through rationalization. You're good already. This is a good answer. All right, now let's do the tangent. So the tangent of 30 degrees is, again, opposite over adjacent. And opposite, again, is 1. So that's x. And that's over adjacent. Adjacent is x times the square root of 3. All right, so let's substitute the 1 in. So we have 1 over 1 times the square root of 3. So that's going to equal 1 over 1 times the square root of 3 is the square root of 3. Now we got, in the denominator, we've got a radical. So we need to rationalize. So I'm going to just say up here, rationalize. How do we do that? Again, we multiply the numerator and the denominator by the square root of 3 over the square root of 3, which is 1. And so you realize doing this by multiplying it times the square root of 3 over the square root of 3, that's a ratio of 1. Any number divided by itself is 1. 2 divided by 2 is 1. 4 divided by 4 is 1. 1 divided by 1 is 1. Square root of 3 divided by the square root of 3 is 1. So it doesn't change the ratio to do this. That's the nice thing about rationalization. It allows you to get the radical out of the denominator, but it doesn't change the ratio. So this equals the square root of 3. 1 times the square root of the 3 is the square root of 3. And then remember this down here, square root of 3 times the square root of 3 equals square root of 3 squared. And any number squared is the root. Or you could say, all right, square root of 3 equals 9. Square root of 3 squared, rather, is 9. So then the square root of 9 is 3. You can see it that way as well. Bottom line, the answer here is 3. Okay. So that's our answer. Now again, you could get the decimal answer. That's approximately 0.5774. And again, you would do that just simply by taking your graphing calculator. I'll just real quickly do it for once. So if I've got, I want to take the square root of 3 and divide it by 3, I get 0.5773 or That would round to 0.5774, it looks like, which is what I got here. Okay. So that's how this works. And so now let's just use these now for two more IXL style problems. So again, this one, the first one's sort of a repeater. It's just showing you the way you would look at it, though. It's a repeater of the previous example. But let me sketch again a 30-60 right, 90-degree right triangle up here at the top. Let me find my straight edge here. Okay, so you got a 30, 60, 90-degree right triangle. So this is 60 up here. Let's use red. 60 degrees, 30 degrees. This is your right angle. This is your hypotenuse. Okay. And if you remember, we said that x is going to equal 1. Right? And then the hypotenuse side is 2 times x. And we're going to let x equal 1, as we said. And we said that the long leg is x times the square root of 3. All right? Okay, so sine of 30 degrees is going to equal opposite over hypotenuse. And that's going to equal x, we said, was 1. Opposite is x equals 1. So 1 over the hypotenuse, which we said was x. Well, let's just say it's 1 times the square root of 3. Okay. All right, and that simplifies into oh, I'm sorry, I boo-booed this. Hypotenuse is 2x. This is the hypotenuse. So let me change this. So that's going to equal, again, x is 1 over 2 times x. Times x. And that, of course, equals, simplifying it, substituting, 1 over 2 times 1. And so that simplifies into 1 over 2. Okay. So that's the answer you would put into IXL. All right. Now, lastly, we're going to evaluate the cosine. I'm sorry, not the cosine, the tangent. The tangent of 60 degrees. I want to do a little different. So the tangent of 60 degrees we haven't done before. And the tangent is opposite over adjacent. Done it for 30, 60, 90 degree triangles is what I should say. The tangent of 60 degrees equals opposite over adjacent. Okay. All right, and so opposite of 60 degrees, here's 60 degrees, opposite is the long leg. So that's x times the square root of 3. X times square root of 3 divided by, and then the adjacent let's see, is the short leg. It's 1, right? So adjacent is 1. We'll just put x here for now. Okay. So since x is 1, we substitute 1 times the square root of 3 divided by 1. And that just simplifies into 1 times the square root of 3 is the square root of 3 divided by 1. And that's what you put. You can put in either the square root of 3 over 1 or square root of 3. I believe IXL will take either of those. Okay? All right. So that is it. We are done. All right. Take care. We'll see you. Bye-bye.